Hey guys, here's our video for 3-4, and it's basically we're incorporating the distributive property into linear equations. Distributive property, linear equations. Okay. So the basic format of what we're going to write is f of x, I'll write it off to the side here, f of x equals our rate of change, our m, but instead of just regular x, it's going to be x plus or minus a number, and that number is not a y-intercept. It sounds like 1, but it's not. Okay? Alright, so alright, let's read about Alexis. Alexis is a flower vendor who grows and sells her own fresh cut flowers. She has a stand in the city and she distributes flowers to pedestrians during the day. She charges $5 for each. Okay, I'm going to stop right there and remember that each is one of our keywords that tells you rate of change. So that's our slope. Each flower, and each month she randomly gives away 2 flowers for free. So gives away seems to indicate subtract to me, and we're subtracting 2. Okay, so that's interpreting our word problem. Alright, the first thing says identify the independent and dependent quantities. Okay, so let's flash back to that. Okay, independent is going to be how many flowers she sells. And actually, I'm not even going to use the word sell. I'm going to say distributes, because she doesn't sell all of them. There's 2 of them she gives away. And D is going to, or dependent would then be the money that she earns. Okay. Alright, it says write a linear function a of x to represent how much money Alexis earns each month. Use x to represent the number of flowers she sells. Write the function in its simplest form. So normally we would say 5 times the number of flowers. But we got something special going on. The number of flowers actually subtracts by 2. In fact, we're subtracting off the 2 flowers that she gives away before we multiply by the 5, so that has to go in parentheses. So she's only getting $5 for every flower after the 2 that she subtracts off. So that's why it's in parentheses. And if it's in parentheses, that means we can distribute, so we can rewrite this in another way. 5 times x minus 5 times 2 is 10. And that's illustrating the distributive property. And kind of a throwback to some vocabulary from chapter 1. Describe the function. Is it increasing or decreasing? Is it discrete or continuous? Well, it's increasing because as she sells more flowers, she gets money. So the more flowers she sells, the more money she's going to get. Everything's going to increase. Would it be discrete or continuous? This graph would be discrete because you can't sell partial flowers. Okay? And also, pet peeve of mine, do not tell me, yes, so Mrs. Andrews, she could sell just a petal. Well, there's a lot of things that can happen. There's possible versus probable, guys. What's possible, there's a lot of things that are possible, but we have to go with what's likely or what's probable. Probably not going to sell partial flowers. On the next page, we're going to practice subbing in. How much will Alexis earn in a month if she distributes 45 flowers? Show your work. So we can pick either of the equations from the previous page. A of x equals 5 times 45 minus 10. I'll just use the y equals mx plus b1. And if you type that into your calculator, you get 215. So she will distribute 215 flowers. She will earn $215, excuse me, if she distributes 45 flowers. And technically, I should be putting a 45 in the parentheses here as well. Okay? So flowers is represented by X, so I'm subbing 45 in for X. Okay, then we got another substitution. How many flowers does Alexis distribute in a month if she earns $300? So again, same formula. A of X equals 5X minus 10. However, we're going to sub in 300 for A of X. Because this time it's not the flowers, it's not X, it's the money. Okay? And then it's a two-step equation. Add 10 to both sides, and you get 5X equals 310. Divide both sides by 5, and X equals 62. So if she wants to earn $300, she distributes 62 flowers. Let's practice that one more time. We've got Bashir. He's also a flower vendor in a different part of the city, and he sells flowers for $3 each. Where'd it go? $3 each. So that's my rate of change. And he gives away 4 flowers. So I'll subtract off 4 for each month. Okay, so just stopping there for a second, we've got $3 each and X take away 4. Okay, in parentheses. He also earns an extra $6 each month by selling one of his homemade bracelets. So this is just an add-on on the end. He's earning the $6, we're going to add on $6. So when we simplify that, we're going to have 3x minus 12 to distribute, bring down our plus 6, and then we'll combine our like terms of negative 12 and plus 6 and get minus 6. So our final function in slope-intercept form is 3x minus 6. Okay, now for homework, I think I've only assigned 1 through 6 on the homework. Okay, so I don't think that I'm going to do any on the video because number 1 is already done for you, and that leaves you really only 5 to practice on your own. Most of you finished this in class today, so I'm not too worried about it. Alright, thanks. Have a great day. See you next time.